All right, so this next section is all about the math that you should know to be successful in this class. And this is background stuff. We're going to learn a lot more math as we progress through the year. But the first thing you should know is how to put numbers in scientific notation into your calculator. Remember, we don't use the caret button. That's out. That's wrong. We use the specific button the engineers built and put on your calculator. It's the EE or the EXP button. Some of you even have a times 10 button that you'll see there. But what you do when you enter numbers on your calculator is type 3.40 and then hit one of these buttons. You might even have to hit the second function button first. If you have a graphing calculator, usually hit this and then the EE button. What you never, ever, 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 ever do is type in 3.40 and then hit the multiplication and then type in a 10. You never use a multiplication sign when you're typing in a number in scientific notation. You type in 3.40 and then EE or EXP or second function EE or something like that, or even this button if you have this on your calculator. And then you want to tell the computer how many times to multiply 3.40 times 10. So that's where you put your exponent in. So 3.40, then one of these buttons, and then 4. Never hit multiplication. Don't hit times 10. All right, what's the difference between 3.40 times 10 to the fourth and then same number, same coefficient times 10 to the negative fourth? Where would you expect to find a negative fourth on a number line? Well, you should be thinking positive exponent means multiply. Excuse me. So whenever you have a positive exponent like 10 to the fourth, you multiply 3.40 times 10 4 times. So it's going to get bigger, bigger, bigger. So you take that decimal mentally and you say, well, it's going to shift to the right and it's going to keep getting bigger. This negative exponent tells us go the opposite way. It actually tells us to divide by 10. So that means it's going to get smaller. So we have 3/10, 3/100, 3,000, 3/10,000, and then your decimal goes here. So whenever you see a negative exponent, it doesn't mean it's a negative number. It just means it's a small number. So times 10 positive exponent is large, times 10 negative exponent small. But they're still both positive numbers because there's no negative sign out front of either of these numbers. If you look for a number that goes on the negative side of the number line, so here's 0, here's -1, you would find numbers that look like this with a negative sign out front. It has nothing to do with the exponent. This times 10 to the negative fourth, if it's a negative exponent or a negative coefficient, would be found here between 0 and -1, and this positive exponent but negative coefficient would be found past that on the negative line or negative side of the number line. So negative exponent between 0 and 1 or 0 and -1, and then a positive exponent is outside that range, greater than 1. Think positive, big, negative, small. All right, what's the difference between 3.40 times 10 to the fourth and times 10 to the fifth? Well, there's only one set of 10 difference between the two. This is multiplied by 10 4 times. This is multiplied by 10 5 times. So it's going to be 10 times larger than this number. If this was times 10 to the, I don't know, let's say 7th, then you know it's 3 sets. Times 10 to the fourth versus times 10 to the 7th. So it's times 10 times 10 times 10 sets bigger. Well, what's 10 times 10? That's 100 times 10 is 1,000. So it would be 1,000 times bigger if this exponent was a 7 instead of a 5. So just count your exponents. All right, you should be able to put numbers into and out of your or out of scientific notation depending on what they are. So let's practice a couple of those. Wait, come back. Sorry, I lost my screen. All right. Good Lord. Let me just use my hand here. Okay, so the first one, we've got a negative exponent. So like I said, that should tell you divide. Negative exponent means divide. So boom, 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 boom. So 0 point, usually you put the 0 point. And then you fill in 0, 0, 0, 3, 4, 0. So we move the decimal place 4 places. Over here, this is a positive exponent, so that means multiply by 10. So 9.0 times 10 is 90.0. This is a big number that we want to put into scientific notation. We don't see a decimal, so we assume it's here. We move it 1, 2, 3, 4, 5, 6, and that's when we stop. We want one number to the left of the decimal, whether you put it there or not, doesn't matter at this point. So 7 times 10 to the, and we moved it 6 places. Now this one, we're going to move it, but if we look at the number that we see in front of us, it's a small number. It's between 0 and 1. So if we move the decimal, same thing, 1, 2, 3, 4, 5, 6, we want to put it there so there's only one digit to the left of the decimal, 3.43. We don't move it all the way to the end of the number and end up with 343. We want one digit, that's it. Just like over here, one digit. Just over here, one digit, one digit. So 3.43, but we want to tell somebody that this was a small number between 0 and 1. So we want to put a negative exponent. 1, 2, 3, 4, 5, 6. So positive exponents tell somebody it's a big number. Negative exponents tell somebody it's a small number. Now, 1, 2, 8.8. Again, it's a small number. So we say times 10 to the negative second. It's between 0 and 1. And finally, this is a big number. It's greater than 1. So we move our decimal so it lands here. We want one number to the left of the decimal. 1.24. You can put the 0 in if you need to. It doesn't really matter at this point. You haven't learned enough to know whether or not you should. Check your answers quickly. If you use your calculator to run these numbers, you should end up with 4.2 times 10 to the 4th. Make sure if you see on your calculator 42000 and or whatever you end up getting, I guess that would be it. And then you're asked to record your answer in scientific notation, you know to put it into scientific. So you move your decimal and you record 4.2 times 10 to the 4th. Over here, this is where if you use anything but the EE button, you're going to get it messed up. If you type in times 10, if you use the caret, if you use any other creative way of getting scientific notation in your calculator, you're probably not going to get the right answer. So when you do, you should get 2.07 times 10 to the 1st, or 20.7. And then I asked you to put it in scientific notation, so you need to move the decimal point over at one place and record it as 2.0 times 10 to the 1st. All right, real quick, you should know prefixes and what they mean. We took a lot out, so you don't have many to remember, but these are the basic ones that we use quite a bit. Centi is 100 times smaller. Milli is 1,000 times. Kilo is 1,000 times bigger, like a kilometer is 1,000 meters, little meters. And deci is 10 times smaller. You should also know nano. Nano is 1 billion times smaller. So if I'm talking about a nanometer, and here's my meter, I actually divide these into 1 billion parts, and each one of those is a nanometer. All right, take a peek at the standards. You should know these. Check your answers. One that I want to stress is a cubic centimeter. We talked about this when we did density. If we have a box that's a centimeter by centimeter by centimeter by centimeter, and we filled it, so this is 1 cubic centimeter, and we filled it with any liquid, doesn't matter what it is, it would have a volume of a milliliter, a volume equal to 1 milliliter. So 1 cubic centimeter is equal to 1 milliliter. That's volume, how much we have. Now, if I had a cubic centimeter or a milliliter of gold, this would have a mass of 19.3 grams. But if I fill that same box with water, with just water, it would have a mass of 1.0 grams. So volume is different than mass, and density ties these two together. So you should just be thinking these two things are equal. If it happens to be water, it's also equal to a gram. But I could have gold, 19.3. I could have aluminum, I think it's 2.7 grams or whatever it is. Any different substance other than water would have a mass something other than 1. So just keep that in mind. But you should know references for all the rest of these. Finally, heat, and we'll talk a lot about this later on in the year when we do thermochem. Heat always goes from warmer objects to cooler objects. It's always a downhill flow from higher concentration to lower. A lot of heat, less heat. Just keep that in mind. All right, so let's work out these 3 density problems, and that'll be the end of this video. It says, determine the density of the following substance. A liquid has a mass of 63 grams and fills a graduated cylinder to the 52 milliliter mark. So that's the volume. Now we know density is going to be mass over volume. The mass of this particular liquid is 63 grams, and the volume is 52.0 milliliters. So if we divide mass by volume, we end up with 1.21 grams, and it's over 1 milliliter. The grams and the milliliters don't cancel out since they're different. So it's 1.21 grams for every 1 milliliter of the substance. That's the density. Now it says determine the density if it's got a mass of, now again we know density is mass divided by volume, so here's the mass that goes on top, 543 grams, but then it tells you the length and the width and the height. And if we multiply the length and the width and the height together, we'll get the volume. So the first thing we need to do is solve for volume, then we can put it down here and then run the numbers. So let's solve for volume. Let's multiply this length times the width times the height. When you do that, you get about 164.25 cubic centimeters. The centimeters cube each other, or end up cubed. So 164.25 cm3, divide the two, and you get, for a final answer, density equals about 3.3 grams, again the units don't cancel, for every 1 cubic centimeter. So if I had a little box of this sample, and it had dimensions of 1 cubic centimeter, centimeter by centimeter by centimeter, then it would have a mass of 3.3 grams. If I put it on a scale, that's its mass. All right, number 11. We've got a graduated cylinder filled to the 40 milliliter mark with water. So here's my graduated cylinder. I've got it filled up with water to the 40 milliliter mark. Then a bead with a mass of 45 grams. So the mass of this bead here is 45. It's added to the graduated cylinder. So somebody drops in the little bead. And what happens? The water level increases. So the water level now goes up because the bead's in there. And the bead's taking up space, which causes the water to go up. And it goes up to the 55 milliliter mark. So we know it started at 40 with no bead, and then we put the bead in, it goes up 15 milliliters. So that means the bead is equal to 15 milliliters. It started at 40, so 40 is the initial, 55 is the final, and you subtract the two, and you get 15. So anyways, 45 is the mass, 15 milliliters is the volume, divide the two, and you get 3, and you always have to put a unit on it, so it's 3.0 grams for every 1 milliliter.